The next is going to be 27 by 27, which is going to be 9. The next is going to be 36 by 36, which is going to be 16 of those squares. So if you're familiar with the inverse square law, I'm doing the inverse square law, which is 1, 4, 9. I'm sorry, I said 16. It should be, yeah, that's right, 16. It's going to be 16. So depending on your grouping, how many of these you have to make a torus, you get more and more spires. And you get more and more conductors and more nested vortices circuits with different amounts of vortices. So they have to be constructed perfectly and phased perfectly to get the right effects. Otherwise, you're cutting across the circuits in a bad way, and the motion doesn't occur correctly. It's not centered on its axis like it should, and the magnetic fields will be much weaker. All right, so here everything's one spire in a 9 by 9. Now here I have 18 by 18. You can see it's 4 times the size of this one. All right. So if I put one of these, it'd be 1, 2, 3, 4. And now I have 2 spires. One is my reds here. So if I connected these end to end, what it would really look like, that diagonal motion of the red tiles this way, it would look like this. You would be seeing this spiral over the surface of the toroid. So that's what I'm showing you. My regular doubling circuits on this model are here. They're going from red to green to red to green. So they're doing the positive, negative, positive, like that. Red to green, red to green. Those are my regular circuits. But my spires are going across. Now once I do 18 by 18, I'm going to have 6 nested vortices circuits. And I'm going to have 12 conductors, and I'm going to have 2 spires. All right, so I'm going to have the red ones and the green ones. And it's very interesting how these spires polarize. It's very significant. It's what's trying to be achieved in the standard Rodin coil, but I believe that because of the additional complexity of this, which is far beyond what's being done, in that it really changes how you have to do it to create the field. Ultimately, what these coils aren't even electrical coils. They're field generator coils. What we're looking for is the secret of magnetism. So here, again, is a 27 by 27 now. So all I mean is I got 27 on my vertical, 27 on my horizontal. Now with the 27 by 27, remember I had 3 nested vortices circuits here, 6 here. I'm going to have 9 nested vortices circuits here, which means I have 18 different wires, 18 conductors, polarized. I also have now 3 spires. I went 1, 2, 3. You can see just the added colors. Went from red to green to red to green and orange. So now I have 3 spires going over the top of the circuit. So you can start to see how this is a clear algorithm. It's complete, true, whole number fractal. Interestingly though, while my spires change, just like I was showing you here, or on this map is the same thing, my nested vortices sequence numbers never have to change. It's just that the more you add of these groups of 9, the more spires you get. But the sequence orders never changes. So when you're modeling, this is really the secret to modeling the atom, doing the periodic table. So I guess I'm giving it away. Let me look at this one. Here's a 36 by 36. All right, you've got, now I have, I'm going to have 12 nested vortices. Notice if I do family number groups too, so if I'm doing family number groups and I say this is 1, for instance, because I have 1 spire, 1 group of 9 by 9, now when I'm basing it on, anyway, it's too complex for me to say in words what I'm trying to say, which is the relationship of the way that these numbers multiply together. Some are multiples of 3, some are multiples of 6, some are multiples of 9, some are multiples of 1. So when you want to model a progression, it's all based on this. This is the way to do it. So back to what I was saying, a 36 by 36, I have now got 12 nested vortices circuits. I've got 24 wire conductors, if you're using wire, or 24 pathways is what I would prefer to say. I don't think that this kind of coil can be built in a standard way. It's going to require a better construction. So I have that many, and now I've got 4 spires. All right, but I've just been showing you the spires. I could also show you the patterns of how the spires are polarized, and I won't explain this, but here's now my 9 by 9, but I've got 2 colors representing my positive and negative aspects. And again, these are interlaced, when you put numbers to them, interlaced doubling circuits, giving you all your numbers over top of the numbers. If that makes sense. So here's the positive and negative for 9 by 9. Here's 18 by 18. You can just follow the pattern. 27 by 27 is getting more complex. 36 by 36. It just goes on and on. I have the pattern to scale it from micro to macro to infinity. Okay, I can show you here. This is in base 50. This is a 49 by 49. You can do the same thing. The algorithm always holds up. So this is, in order for you to maintain the principles of your symbol, to have your unbroken multiplication series and circle modeling truly 3D, to have your doubling circuits, this is the only way you can do it. You have to have a minimum of 3 nested vortices circuits. That allows these vortices to sequence. When they do, you can get this effect. This is the electrical venturi. Okay, as the doubling circuits are winding in this yin-yang pattern, which I showed in my other video, you get these spires going over, and notice they're always in quadrature. All my 3s are here in quadrature, my 6s are here in quadrature, my 4s are here. So as the number groups and the vortices are sequencing, you actually are still maintaining this pattern of the spires, but they're along this arc of this logarithmic spiral. So it's a much more complex sequence. I do have it. I have the understanding of the sequence to make perfect mirror imaging and to be able to construct any coil and any multiple of this and to connect it with every single geometry. That's basically what I found. You can do every single geometry simultaneously by modeling these emanations and their over interlacing spirals.